Hello, children. Today, we'll discuss angle relationships. Last time we talked, or last time I made a video, I discussed just angles in general. What an angle is: two rays that intersect at a common point. That point is called a vertex. Things of that nature. Today, we're going to start off with a couple of definitions. And first is stuff that we will see all the time. You will see the word complementary, supplementary, and adjacent many times this year. And we need to understand what each one of them means because they have a specific meaning and they're trying to tell you a lot. Complementary are angles whose sum is 90 degrees. That means angles that when they add, that's the word sum, together is 90 degrees. Supplementary, angles whose sum is 180 degrees. So again, angles that when you add them together, they equal 180 degrees. Now keep in mind what 180 degrees looks like. We talked about a straight angle being 180 degrees, okay? So if two angles add up together to make that straight line, it's 180 degrees. Adjacent angles, two angles that share a common vertex and a common side. In other words, two angles that are right next to each other, but they share a common vertex and a common side. Now, what I have here is, notice that I have a right angle here. And I got the little box here. That's how I know it's a right angle. Not just because it looks like one, but my little right angle box there. Notice angle 1 and angle 2 are adjacent angles. They share a common side, this side right here, and this same vertex. So they're right next to one another and they share a side. They're adjacent. It says angle 1 and angle 2 are adjacent and complementary. How do I know that they're complementary? Because put them together and they equal 90 degrees. You take them away, they don't equal, but when you put them right next to one another, they equal 90 degrees. Now, angles 3 and 4 are adjacent and supplementary. That means they share the same side and the same vertex right here. That doesn't have a point there, but it's a vertex right there. They're adjacent and they're supplementary. They add up to be 180 degrees. How do I know that? Because it's a straight line. Anytime we see that, we can say that. All right. Now, angles 5 and angle 6 right here are non-adjacent, or they're not adjacent. They're not right next to each other. Okay, so that's an example of angles that aren't adjacent. Now, go back and review that, or pause and write that stuff down if that didn't make sense to you. What adjacent is, right next to one another, and what complementary is, and what supplementary is. All right. Next, a linear pair. Angles are linear pairs if their non-common side are opposite rays. All right. Their non-common side are opposite rays. Okay. So a lot of times linear pairs just look like this. Linear pair, they make a straight line. It's basically what you'll see. All right. Anything like that is a linear pair. And linear pair always add up to be 180 because it makes a straight angle. Okay. Vertical angles. Sides form two pairs of opposite rays. And I always say it look like an X. Vertical angles are two pairs of opposite rays. So in other words, you got this X right here. And it says angles 3 and 6 are vertical angles. Angles 4 and 5 are vertical angles. So the ones that are across from each other are vertical angles, okay? So 3 and 6 are vertical. That's what number 5 is talking about here. 4 and 5 are vertical. But notice that angles 3 and angles 4 are a linear pair. Angle 4 and angle 6 are a linear pair. Angle 6 and angle 5 are a linear pair. Also, do you see that? Even though I'm talking right here specifically about vertical angles, this angle here, oh, that was big. This angle here, 3, angle 6 are vertical pair. Angle 5 and angle 4 are vertical pair. Excuse me, are vertical, yeah, vertical pair or vertical angles, yeah. Now, a linear pair would be those two. Those would be a linear pair, and I'm using my mouse, so I'm terrible. And those two would be a linear pair. And those two would be a linear pair, because they all are forming straight lines. And these two would be a linear pair. Alright? Now it says, identify all linear pair and all of the vertical angles. Okay? So you may want to write this down. I'm just going to talk it through. Linear pair means you got two angles. So notice angle 5 and angle 1 are a linear pair. You see that? Angle 1 and angle 5 here are a linear pair. Notice pair means two. Alright? Angle 5 and angle 4 are a linear pair. Alright? Now the problem is I can go from 4 to 2, but is that two angles? That's 4, 3, and 2. So that couldn't be a linear pair because it's three angles. And if I wanted to go 3, 2, 1, it does make a straight line, but again, that's three angles, so it's not a linear pair. So we have 5 and 1 here, and 5 and 4 that make a linear pair. Now let's see if we have any vertical angles. The vertical angles I see are angles 4 and angle 1. There the X is, and they're across from one another. I can't say 5 and 2 because it doesn't give me that opposite ray thing, two pairs of opposite rays. Here's two pairs of opposite rays. There's one pair and there's the second pair. So the only set of vertical angles are angle 1 and angle 4. Take a look at that picture and make sure you can understand that you have to have that X, and the only place that X is right here with 1 and 4. Alright? Now, let's see what else is here. We have this example, and they want us to find, oops, no you don't, that's my bell work, so you don't want to worry about that one. I believe that's it for today, so let's review real quick. These definitions, complementary angles whose sum is 90 degrees, that's important, complementary angles. Supplementary, so I'll just say supplementary from now on, and complementary, you'll know, but supplementary is 180. And adjacent means right next to, two angles that share a common side and vertex. And 2 and 1 and 3 and 4 are examples of adjacent. 1 and 2 are examples of complementary because they add up to be 90. 3 and 4 are examples of supplementary because they add up to be 180. And these are non-adjacent. They don't share a common side. Next, we talked about linear pair. Basically, they make a line, a straight line, two angles that add up, and it has to be 2. Okay? It says their non-common side are opposite rays. So this is the common side that they have in common. These are the opposite sides, the non-common sides, and they're opposite rays. Vertical angles, you have whenever you see this X shape. It always happens. And the angles that are like opposite one another turn out to be the vertical angles, like 4 and 5 and 3 and 6. Okay? And so that's what today's lesson is about, is understanding a little bit more about linear pair and vertical angles. Now before we go, I like to work out an example with you. Now this is based on something that showed up in our last set of notes. So the last set of notes we talked about a bisector, and so it really kind of fits more in today's notes, and so I just want to review real quick before I end the video. Here's an example. I have information that tells me that ray, that means ray, GH, this one right here, bisects angle F, that's a F, not a 7, FGI. So here's FGI, and I know that this angle right here bisects. I know that not because of the picture, but I know that because of what I was told, and my instructions are to solve for X. Okay? So let's understand what that means. A bisector, if you go back to those notes, it says that a bisector cuts an angle into two congruent parts. Now, those double slashes or double lines mean that this angle and this angle are the same. I couldn't put it there because I ran out of room. So what does congruent mean? Congruent means that their measures are the same. So what that means as far as understanding what to do, if I need to solve for x and I'm given expressions that look like this, I need to know which equation to set up. So do I add these together to make them equal 90 because they're complementary? No, nothing says that. Do I add them together and set them equal to 180 because they're supplementary or a linear pair? No, nothing says that. Do I subtract them? No, I have no reason to subtract them. The only thing that I know about these two is that this angle and this angle are the same. And if they're the same in math, then we say that they are equal. Okay? So now I have an equation that I can solve for x. I'm going to subtract 3x. I always move the smallest number out of the two. So that's negative 3 equals x minus 14. So I'm going to add 14 to both sides, and I get that x equals 11. So that's an example of using an angle bisector. I know that this line or this ray cuts this angle FGH into two equal halves. And once I understand the definitions, which are going to become very important in geometry, then I can apply them in my instruction. All right, guys. Good luck.